Hi, this is Joe Maciarz from Tutoring Enterprises. Today I want to continue with quadratic equations. We've been studying how to change the standard form equation into the vertex form by completing the square. Today we're going to look at y equals 3x squared plus 24x plus 42. That's our standard form, and we're going to go over to the graphing calculator and start to talk about turning this into a vertex form. To do that, what we're going to do is we're going to go ahead and look at these first two terms on the right-hand side of the equation, and we want to get a 1 there in front of that x squared. Now the way to do that is to basically pull out the 3 from those two terms. We're going to ignore the 42. It's going to tag along with us, but we're basically going to ignore it as far as completing the square is concerned. So when we pull a 3 out, we're going to have left the x squared, and when we pull a 3 out of this, that's the same as asking, well, what's this divided by 3? That's going to be an 8. So we're going to have plus 8x. Now remember, I told you that what we're basically doing with completing the square is we're adding a 0 in there because we don't want to change the equation. Now, we want to add the 0 in a very specific way. Specifically, we want to take this 8 and we want to divide it by 2. So 8 divided by 2 is 4. And then we want to square that. So that's going to get us 16. So we're going to change that 0 to a 16, but I need to keep it 0, so I'm going to subtract 16 because 16 minus 16 is our 0. Now we're going to add that 42 that is tagging along from the original problem. Okay. From here, what we're going to do, and then of course that's giving us an equation. We're not interested in what that looks like right now. We're interested in how to take this equation, turn it into completed form, and graph it by hand, basically. So what we're going to do is we're going to go ahead and break this now into two pieces. So let's get the new equation. The first piece is going to have the first three terms inside the parentheses here. So we're going to have the x squared. We're going to have plus 8x, and then we're going to have plus 16. Now, the remaining negative 16 we're going to pull out, and we're going to have to remember that we need to multiply the 3 with that negative 16. So 3 times 16 is 48, but we have that negative sign there, so we're going to end up with negative 48. Plus, we have that 42 that's still tagging along. All right. And again, we're not really interested in that equation, so I'll turn that off. Again, you can keep these on if you'd like, just to check if you're using the Apple Grapher. Of course, if you're trying to graph with these equations, well, then there was no need to turn this into vertex form. So it sort of defeats the purpose. But let's continue going. The terms inside the parentheses are now a perfect square. So how do we figure out what to write down? Well, we're going to take the square root of this first term, so that's going to be an x. Then we're going to take the sign of the second term, that's a plus sign in this case, and sometimes it will be minus, you have to see what's actually here. And then we can take the square root of the third term. Now there's a couple other ways of doing that, figuring out what that 4 is, but we're just going to leave it at that. And remember, we're completing the square, so that means it becomes x plus 4 squared. Now the remaining two terms, negative 48 plus 42, we're going to put those together and simplify it, and what we're going to get is minus 6. Okay? And that's it. That's our completed form. Again, we're not interested in the graph of that at this point. We're going to try to graph it by hand. So let me also put in here, for the sake of just viewing it, our vertex general form, which is going to be y equals a times the quantity x minus h squared plus our k. And it's going to yell at me because it doesn't know what to do with a, h, and k again, but we don't care. We're just using this to highlight the different things. We can see that a is going to be 3, and because it's a positive number, we know that the parabola is going to open upward. We also know that h is going to have to be negative 4 to end up being positive 4, or to have x plus 4 up here, and we can see that k must be negative 6. So we can see that our vertex is going to be negative 4, negative 6. All right, let's go ahead and put in a point for that. Remember, we come to the template and choose a parametric Cartesian curve to do that, which we, of course, throw away the parametric part. And I do promise someday I'll actually show you what that stuff does, but not today. And we said we're going to put in -4, -6. Okay. And I'm not going to mess with the style of the point. We can see that it is at -4 on the x, -6 on the y. Now, to get the rest of the points, this one's a little trickier than what we did last time. You might recall that we were looking at a particular pattern. When a was equal to 1, the pattern was that we would go over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7, and so on down the line. But a is not 1 here, a is 3. So what do we do in that case? And again, it's not going to like this equation. It's going to yell at me because it doesn't know what to do with this. But that's okay. It's just for observation's sake. Well, in our case, a is equal to 3. So what do we do? Well, all we've got to do is take each of these and multiply it by whatever a is. And let me say the absolute value of a. So what we're going to have then is 1 times 3, which is 3, 3 times 3, which is 9, 5 times 3, which is 15, and 7 times 3, which is 21. And of course you would continue that pattern. 9 times 3 would be 27, and so on down the line. Okay, well I've already taken the liberty of putting in some of these other points, but I'm going to slowly put them on as we go along. What you would do is, if you were graphing this by hand, is of course you would plot this point just as we did here, and then you would go over 1, which puts us around -3, and then you're going to go up by 3. That's what we've got here. So we're at -4, -6, so we go over to -3, -6, and then we go up 3. So 1, 2, 3, and you can see we'll end up at -3, -3. Well, I prefigured out that point, and there it is. Again, we can get the other point just on the other side of this by going over 1 from the vertex, so to -5, and then up 1, 2, 3, so -5, -3. And there's that point. Okay. The next point, we're going to go over 1 and then up, here it is, 9. So it's a little bit more, but it's 1, 2, 3. So now we're at y equals 0, and then we're going to have to go up 6 more, which will put us up at 5, 6. So -2, 6, which is this point right here. And then we do the same thing from here. We go over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we'll end up at, what's that, -6, 6. And we turn that on. Okay. And just to verify that those are the correct points, we can turn that equation on, and indeed the parabola is going right through the middle of all of those points. Now you would draw a nice smooth curve if you're doing this by paper because you don't have an equation you can click on like I do. But that's basically it. Now the next video that I'm going to do, I'm going to give us something a little bit different than what we've just done here. Instead of a 3 here, I might do a fraction like 1/2 or 1/3 or something. And I'm also going to put in a negative sign just to give it a little bit of change in flavor. And we're going to examine what do we do in that case. It's very similar, but we're going to get a different style graph. Notice that here a was equal to 3. What did that tell us? Well, it told us two things. It first told us that it opened upward, but the second thing it told us is that it was narrower than standard. Well, what was standard? Standard was the graph y equals x squared. So if I had put y equals x squared and took it and grabbed it and put the vertex here, I would see that this would be narrower than that particular curve. So if I put a fraction over here, what do you think is going to happen? Well, if you don't know, you might want to go check out the video I did where we were looking at the parameter a with quadratic equations to see what will happen. Other than that, I'm going to leave it as a little guessing game for the next time, and you'll have to check out the next video to see what will happen once I put a fraction in here. So that's it for this one today. Let's go ahead to the final screen at the end. Again, this has been Tutoring Enterprises, and we were studying the quadratic equation 3x squared plus 24x plus 24. And we were turning it from that standard form into vertex form by completing the square, and then we were graphing it. So this has been Tutoring Enterprises. My name is Joe Maciarz, My website is at www.tutent.com, and my email is at tutent@neb.rr.com. And if you're interested in an appointment, whether it be local in Lincoln, Nebraska, or in the world or around the globe, give me a call at 402-421-3536, and we can set up an appointment and give you a helping hand. If you found this video useful, feel free to donate $1 to my PayPal account. I am trying to get new equipment and make some things work here with the latest stuff. I'd like to make some better videos, but just think of this as shareware for the brain. So if this video actually helped you out, please feel free to donate. And if not, if it didn't help you out, don't worry about it. Everything's fine. I appreciate you taking a look at the video, and hope you have a good day. Thanks.